Section 6-7 is on solving radical equations. And we did a little bit of this in Algebra 1, but we're going to take it a step further and deal with more than just square roots. So a radical equation is basically just an equation that has a radical expression in it. And the x is going to be underneath the square root sign, or the radical sign. So to solve, there's a couple of simple steps. You want to isolate the radical if possible. In other words, get the radical all by itself on one side of the equal sign. Square both sides of the equation, or if it's not a square root, then raise it to a power so that you basically get rid of the rational exponent or the radical sign. Solve for x, and you must check, because sometimes when you square both sides or raise both sides to a power, you can get extraneous solutions, values that don't work. So I know we hate checking, but you're going to have to in this case. So let's take a look at several examples here. So solve each equation. So we have the square root of x minus 2 minus 1 equals 5. First step is to isolate the radical, so I'm going to add 1 to both sides. So the square root of x minus 2 is equal to 6. Squaring both sides, I'll actually take the time to write out the step here. Oops. Square both sides. On this side, the square and the square root cancel out, so I get x minus 2 is equal to 36, and then adding 2 to both sides, x equals 38. Now, do not box that until we've checked it. You have to check. And remember, in order to check, I take my solution, plug that into the original equation, none of these down here, just the original equation, plug that in for x and see if it works. Is the square root of 38 minus 2 minus 1 equal to 5. Okay? And remember, when you're checking, you don't add or subtract on both sides, you just PEMDAS each side of the equation. So, is the square root of 36 minus 1 equal to 5? Is 6 minus 1 equal to 5? Indeed it is. 5 equals 5. It checks. So now I can box my answer. Number 2, square root of x minus 12 is equal to 2 minus the square root of x. Can't really isolate the radical because I have a radical on each side and I can't combine those. So it's a little messy, but I'm going to have to square both sides to start with. The left-hand side isn't too bad. Okay, that's just going to give me x minus 12 because the square and the square root cancel each other out. But right here, I'm going to have to FOIL that. There's no way around it. That's 2 minus the square root of x times 2 minus the square root of x. So I could actually write it out over here if it makes it a little easier to see. Okay, so let's FOIL. First, outer, inner, and last. A negative square root of x times a negative square root of x gives me just an x. Let's combine like terms. So that's going to give me 4 minus 4 square root of x, because I can combine those two, plus x. Okay, but I'm not done. I still have a square root. I can't figure out what x is. So now I go back and I isolate the radical again. So I'll subtract 4 on both sides. So, and then subtract x on both sides. So when I subtract x on both sides, my x's cancel each other out. When I subtract 4, I get a negative 16 is equal to negative 4 square root of x. Dividing both sides by negative 4, I get 4 is equal to the square root of x. Whoops, thinking ahead there, sorry. And when I square both sides, I get x is equal to 16. So let's see if that's going to work. I have to plug that in back in the original problem. So to check, is the square root of 16 minus 12 equal to 2 minus the square root of 16? Is the square root of 4 equal to 2 minus 4? Square root of 4 is 2. That is not equal to negative 2. It doesn't check, so there is no solution to this one. That's that's why you have to check, because sometimes squaring both sides can give you extraneous answers that ultimately don't actually work in the equation. Okay, let's give this one a try. We need to square both sides, well, isolate the radical, which we don't really have to. There's a radical on each side, can't do anything to that. So let's go ahead and square both sides, which is really kind of easy. That just gives me 7x minus 2 is equal to x plus 3. And solving for x gives me 6x equals 5, or x is equal to 5/6. Okay, may seem very easy. Don't box that yet. We have to check it. So for my check, is the square root of 7 times 5/6 minus 2 equal to the square root of 5/6 plus 3. And to check this, since it's pretty nasty looking, I would go ahead and do it in the calculator. Plug in this, and since it's a square root on both sides, do you get the same thing underneath the radical when you do both of those? Indeed you do. Use your calculator, and it does indeed check. So x is equal to 5/6. Okay, in our last example, 2 times the quantity x minus 10 raised to the 1/3 power plus 4 is equal to 0. In order to solve this, it's kind of weird. I don't actually have a radical in this, but I do have something raised to the 1/3 power, which is the same thing as taking the cube root of something. So I want to isolate the expression that's raised to the 1/3 power. So I'll start by subtracting 4. And then I'll divide both sides by 2. Okay, so I have the quantity x minus 10 to the 1/3 power is equal to -2. So I really need to get rid of this 1/3 power. To do that, I am going to raise each side to the 3rd power, because 1/3, something to the 1/3 power raised to the 3rd power, remember you multiply those, that's going to give me just a 1. So I raise both of these to the 3rd power. That's going to give me x minus 10 is equal to -2 raised to the 3rd power is -8. Adding 10 to both sides, x is equal to 2. Before I box that, I have to check. In the original equation is 2 times 2 minus 10 to the 1/3 power plus 4 equal to 0. Don't add or subtract on both sides, just PEMDAS. Is 2 times -8 to the 1/3 power plus 4 equal to 0. So remember, I have multiplication and I have an exponent, so I need to do the exponent first. Remember, 1/3 power is the cube root. You can do this in your calculator, and it'll give you the right answer, or you can think what number times itself 3 times gives me a -8, and that's going to be a -2. Oops, forgot my question marks. Okay, so is -4 plus 4 equal to 0? Oops. Indeed it is. It does check. So x is equal to -2. So when you're solving a radical or even a rational equation, isolate your radical or your rational expression, square or cube or raise to the power both sides to get rid of that, solve for x, and most important step of all, you do need to check.